Okay, today I want to talk to you about how to calculate average atomic mass. Average atomic mass is the weighted average of all the isotopes, and this is the decimal number that you find on the periodic table. It is typically, it's a weighted average of all the isotopes. So let me explain the difference between a weighted average and a straight average. A straight average is what you're used to, where you take numbers and you add them together and divide up by how many you have. So example, if I was looking at boron 10 and boron 11, if I was doing a straight average, I would just add the two numbers together and divide by 2, and you would get 10 and a half. So that's saying boron 10 and boron 11, I have equal amounts. Well, it's different for isotopes. We don't have equal amounts of the different isotopes in the Earth. We have a percent abundance amount. So if you look here, boron is 20%, boron 10, and 80% boron 11. So what that means is boron 11 is going to have a greater impact on the average atomic mass than boron 10. Now boron 10 is still going to have an impact, but not as big as boron 11. So the formula for calculating average atomic mass, I'm going to call it AMU because that's the units for it. You're going to use percent abundance, and this is this number here, times the mass, plus percent abundance, times the mass. So what that means is boron is 20% boron 10. So 0.20, so that's 20% times 10. So I changed the percent to a decimal, and to change a percent to a decimal, you just have to divide it by 100. Then I'm going to take 80%, so I'm going to change that to a decimal. I'm going to take 0.80, and I'm going to multiply it by boron 11. So what you want to make sure you're aware of, since I have 80% of boron 11, that means my average atomic mass is going to be closest to boron 11. So when I do the math, I should get 10.80 AMU. I know this says to the tens place, but we're going to really write it to the hundreds place. And you can check your answer to see if you're close to the value on the periodic table. If you're close to the value on the periodic table, then that means you are correct. So let's look at another example. Because of all the existence of isotopes, the mass of a collection of atoms has an average value. So if you look here, lithium has two isotopes. It has lithium 6, which is 7.5%, and you have lithium 7, which is 92.5%. So when you're calculating this, you should understand that your AMU of lithium should be closest to lithium 7, not lithium 6. So what you're going to do is you're going to take 6 times the percent abundance. So I got to change my percent to a decimal. So it's going to be 0.075 plus lithium 7, which is 7 times 0.925. So when I do the math, I'm going to put this in my calculator, and I'm actually going to put it in one step, and I'm going to tell you how to do this. So what you're going to do is you're going to do parentheses 6 times 0.075, close parentheses, plus 7 times 0.925. And when you put that in your calculator, what you're going to get is a number of 6.925 AMU. Now, earlier in the video, I said you're going to round it to the hundreds place. So your average atomic mass for lithium is 6.93 AMU. So I'm going to do another example. So now instead of having 2 isotopes, you have 3 isotopes. So there's no limit on the number of isotopes, just so I want to make you aware. You could have 2, you could have 3, you could have 4, have 5. It just depends on the element. So let's look at silicon. So silicon 28, I'm going to take 28 and multiply it by the percent abundance. But again, I have to change it to a decimal. So 0.9223 plus silicon 29 times 4.67%, so 0.0467 plus 30 times 0.0310. So I'm going to put that in my calculator again, put it in as one step. And if I put that as a one step, I will get 28.11 AMU. That should be AMU. So this should be my answer here. So you can always check your answer by looking at the periodic table. So if I check silicon's average atomic mass value, for silicon, I got 28.08. So it's pretty close. Now, you might get different numbers because your percent abundances might be a little different from resource to resource. So as long as you're close, you're going to be good. So this is how we calculate average atomic mass. If you have any questions, email me, and I will do my best to answer every email. If not, I can always set up a Google Meet for those of you that are quarantined. I believe the last page in the packet is average atomic mass. So that will be your homework that goes along with this. Thanks, and I will talk to you soon.